Today's presentation is going to be about concrete mix design submittals by Frank Kozlowski of Gallup, New Mexico. Some of the information that we will touch on today in the submittal is number one, talk about the concrete mix design. For instance, say 3000 psi with some test reports. We're going to want an ACI 214 summary. Another mix design could be the 4000 psi exterior with entrained air, and a computer look at the mix design. Then the ACI 214 summary of a 4000 psi mix design, along with the screen analysis of the aggregates. We also want to include some test reports on the aggregate, the cement and fly ash certificates, certifications of the plants and scales, information on the admixtures, initial curing standards, how the cylinder should be cured. In this case, it was for New Mexico, along with the government required MSDS sheets for the mix design submittal. The mix design submittal should include the client's name, the project name, a location of the project, along with the bid date, because many times projects are bid and you don't get a request for a submittal for at least 6 months. And the mix design submittal should have everything, and it would then be in accordance with ASTM C94. It would meet the requirements for 318, ACI 301, and ACI 211, the guide for submittal for concrete. The submittal should indicate if the mixes are performance-based and designed, say, for a 4-inch slump. And if a 4-inch slump is requested, superplasticizer can be added to increase the slump of the concrete. And this submittal will set the game plan for the mix and establish a plan for the concrete contractor. The first sheets tell a little bit about the mix design on the left, and then on the right is a copy of a page out of 318 is to the step-by-step procedure to have the mix design submittal to be approved by the engineer. And the information about the mix design, we should say in there that the mix designs are performance-based. All the mix designs that I did when I was with Gallup Sand and Gravel were combined aggregate gradations, and based on past history they had the same fly ash and cement over a number of years. The mixes were not prescription based. The proportions were my responsibility as a producer. I took that responsibility. I included a blended aggregate to give the clients the best concrete for the intended use. The mix design guidelines on the submittal. One thing we had to do is to make sure that all testing was done by certified ACI technicians, is outlined in ASTM C94, because you want to make sure that anybody testing concrete is ACI certified. And along with making the cylinders properly, I specified in my submittal that cylinders had to be properly cured so that the test specimens would not lose any moisture. Basically, they were immersed in water between 60 and 80 degrees, because if improper curing for the first 20 hours was not properly done, we could have a reduction at 28 days of 800 to 1000 psi. Now, this is a Thermo 2 curing box that we had purchased and taken to a job site. These 8 cylinders show them in the curing box. However, water is to be added so they're completely submerged. These are in the water, and the temperature is set at about 73 degrees, and they'll go up or down about 2 degrees. Keep them at that temperature. If you fill it with cylinders, it runs on the cool side to keep the water cool, so the cylinders do not get over 80 degrees. Another box was for test specimens. This one looked like a freezer, and we would put in 8 5-gallon buckets, each with 4 cylinders, and each bucket was filled with water. The cylinders were placed in this cooler, and this cooler again was another method of keeping the water bath in the cylinders between 60 and 80 degrees, and this was done at a job site. This tends to be a dry box, as I would call it. And the reason we were very concerned about the cylinder testing is that in New Mexico some years back, approximately 15 or 20, we had a number of testing labs in Albuquerque that tested one single mix design, and they took the data, and it's been published by the New Mexico Ready Mix Concrete Association. And as you can see here, where the cylinders that were exposed, left out in the sunlight like we do normally on job sites, had the lowest 7-day breaks, or 7-day cylinders, and then they were about 750 psi lower than the thermal tube carrying box, and also a lot lower than the cylinders that were immersed in water. So we found out that based on ASTM standards, if the cylinders are properly cured in a moist environment between 60 and 80 degrees, you will get the 28-day test results. And like I said earlier, you can be 800 to 1,000 psi higher at 28 days based on the initial 24-hour curing. And these curing boxes and setting up the procedures to establish how the cylinders are to be cured eliminate a lot of problems. The box was placed by the producer, and when the boxes were used, the cement efficiency was over 8 psi per pound of material with coefficient of variation of less than 8%, showing that the producer had very good quality control. On other projects where the laboratory did not want to use a curing box, the cement efficiency was down to less than 8 psi per pound and a coefficient of variation of about 16%. And also many of the cylinders did not make the 28-day strength, resulting in very bad quality control. So if the cylinders are not properly cured during the first 20 to 24 hours or over the weekend, you're going to have a lot of problems. The next thing in the mix design was the mix designs themselves. All the mixes that I used were performance-based, and we actually used 4 aggregates. We used coarse, 1 inch by half, half by quarter, 3/8 by 30 of washed sand, and then water. And this gave us combined aggregate gradation and had very good workability. Our mix designs looked like this, where we had 440 pounds of cement. You had the fly ash. You gave the percent of the total cementitious material was fly ash. This was a, as you can see, a 6.3 bag cementitious mix, and we had all the specific gravities for the cement fly ash, each of the aggregates along with the water, and we had the amount of water reducer. In the winter we would use a 997, in the summer we'd use a retarder. Gave us the batch weights, gave us the total cubic feet of material that went into the mix for this particular project. The water cement ratio was 265 divided by 595, giving us a 0.45 water cement ratio. The mix provided a yield of 27 cubic feet, and this gave us a plastic unit weight 144.7 with 3% entrained air. I would then do a theoretical unit weight, and it came up to 149.18 pounds per cubic foot to verify that the entrained air using ASTM 138 would be a check of the plastic unit weight versus the theoretical unit weight to make sure that the air entrainment was correct. I'd like to point out here that the New Mexico DOT has established the unit weight as a method of determining the amount of entrained air in the concrete, because with the unit weight we had more uniform and trained air than we did with the pressure meters. Also, I would specify that all test specimens had to be done in accordance with C94, paragraph 14.3. And note, put in there that the mix was proportioned using combined aggregate, saturated surface dry aggregates, and that the corrections for moisture content in the fine and coarse would be made at the batch plant, so that we were at a 3 to a 4 inch slump. And we reserved to make changes in the proportion based on any changes in the material. However, as the owner of the coarse aggregate crusher, I was able to maintain the gradations that we needed for concrete. Then I also put on the mix design sheet that should a higher slump than 4 inches be required, like an 8, that we could use an admixture called a high range water reducer. This would increase the slump but not change the water cement ratio, and the concrete resort back to its normal setting time in about an hour. And this was some of the information that we put in the back of the submittal about the admixtures, and if fibers mesh was used, or a fiber that 1.5 pound dosage could be added to the mix with no changes, and also that a non-chloride admixture could be used in the winter to increase the set time when used with warm water. This way it eliminated the need for another mix design for the winter. So we had everything covered, winter, summer, fall, for the job site, so we did not have to redo mix design submittals. Then we would have some backup test reports for the mix. I would get these from the testing lab that was on jobs doing the testing, and I made sure that the testing labs had their people were certified, and also that the cylinders were being properly cured the first 24 hours and taken back to the lab, and that they were cured, and all the test cylinders or the technicians who made the cylinders were all ACI certified. Then I would include some statistical analysis. Everybody's looking for some charts. Here's a bell curve on the left with the frequency distribution analysis of a 4,000 psi. Then on the right we had an ACI 214 summary of the average of the 47 tests, the standard deviation, coefficient of variation. Everybody likes to see a few statistical charts, and I would then have supply a tabulated results of all the cylinders for this particular mix design submittal. These were the days cast, included the air temperature, the concrete temperature, what the air content was, the slump, the 728-day compressive strengths, the 728-day ratios, and then the cement efficiency. The cement efficiency tells you what the PSI per pound of cementitious. This is a good way of monitoring your mix designs, knowing where they are, and seeing if they are operating properly. Then with my computerized mix design we were able to put in basically the same information that I had on my manual sheet, but this was a computer generated sheet where I had the cement, the fly ash, the specific gravities were on the right. Then they provided the yield, then the water cement ratio, what the high and low slump were, what the high and low slump would be with superplasticizer. It would give me the concrete unit weight, so that the engineer had as much information as possible for the concrete mix design to go in with the submittal. Then I would include a chart with the coarseness factor and workability, because the engineers were going to have to learn in years to come about a coarseness factor chart and a workability. So I would include this with the mix design submittal as part of my computer generated mix design and what it looks like using a computer. Then I would give the full gradation Gradations were basically aggregate 1 was my 1 inch by half, aggregate 2 was my half inch by number 4, aggregate number 3 was a crushed limestone sand, which was a 3/8 by number 30. Then the aggregate 4 was a washed concrete sand, and aggregate 5 was the same crushed sand that would put together to give us a combined aggregate and a total gradation on all the material and what it looked like. Then I would give a percent retained gradation so that they would start looking at the percent retained, because there are many things out there to study the aggregates, because we do not want two peaks. We want a design where the aggregates is like a slide. You go up the steps and then you slide down. That's what we want with our percent retained, or a haystack, what we're looking for. We do not want two peaks. Then lastly, there was a 45 power curve, and what the 45 power curve does is provide a maximum density for all the aggregates. You start with the large aggregates, keep filling the voids, and if you follow a 45 power curve line, you basically are packing all the particles into all the different voids. This was just some information to supply to the structural engineers what the mixed design looked like on a computer generated graph, other than just looking at the mixed design and the how much rock and sand was in there, and not knowing how the particles really packed together. Then I would include a screen analysis showing that in this case the washed sand with some crushed sand, when combined in an 85-15 combination, we were near the ASTM gradations. We had a fineness modulus for this combined aggregate gradation. The material was washed sand coming out of Albuquerque and crushed sand coming from Theroux. With the bulk specific gravity of the fine and the coarse, or the fine natural fine sand and the crushed fine aggregate, what the average bulk specific gravity was, along with the absorption of the washed sand and the crushed, and that the natural material was natural sand and crushed limestone and cubicle. Also provided the magnesium and sodium soundness loss, along with the sand equivalent number, because many people would like to know what the sand equivalent is, even though it does not play a part in a lot of our mixed designs. Then the other part was the coarse aggregate, where we had 1 by half, half by quarter, 3/8 by 4, and we would combine them back together to get our number 57 stone. As you can see, we could generate the combinations with the 3 aggregates to meet the number 57 stone. All my mixed designs were a number 57. We never played with a 3/4 or 1.5 inches. The 1 inches, everybody was able to use it with no problems. Again, we had the average specific gravity of all the material, the average absorption, where the material came from, the quarry location, what type of material it was, what the LA wear was, the fractured faces, the rotted unit weight, again the soundness loss being the magnesium and sodium soundness losses. Then every 6 months I would take the aggregates to the laboratory in Albuquerque, and we would do a soundness loss, and then we would do absorption, specific gravities, LA wear, fractured faces, and a lot of this information for the New Mexico DOT for their work. So these aggregate tests were used for our normal concrete mixed design submittals. The next thing I would include in the mixed design was a fly ash test report from the supplier of the fly ash, and the cement certification. These were always provided to be hopefully within every 6 months. They can be very easily emailed to ready-mix producers on a weekly or monthly basis, whatever one would want. Then we started including the certification of the concrete plant, along with the certification of the mixers, what type they were, what their unit numbers were. They were always checked on a regular basis for any buildup and cleaned out. And this included some of the information that we would include with the National Ready Mix Concrete Association. So if somebody wanted to check a mixer number, they could check the unit number, see if it was a certified ready mix truck. The next thing we would attach would be the scale certifications for the plant. The scale certifications were done by, as you can see here in this case, the Fairbanks scale people, and this certification was for each of the plants that we may have to batch out of in case one of them went down. And I would include some information on a super plasticizer, and this was a little formula I came up where we would use 2.5 ounces times the cementitious material times the inches of slump that you wanted would provide us the ounces of super per cubic yard. Example, we had 500 pounds of cementitious material, and that was 5 ounces per hundredweight. We wanted to increase the slump 3 inches, so we would take 2.5 ounces times 5 times 3, which would be 37.5 ounces of super per yard, or 1125 milliliters per yard, or basically it came out to 1 gallon of super to 3.5 cubic yards of concrete with 500 pounds of cementitious. This formula appears to have worked. We would use it with most of our 9-yard and 10-yard trucks. We would add 3 gallons of super plasticizer, and the slump would get up to about a 8-inch slump, and we had no problems with it, but it was a way of measuring it with using the formula as to how much super you needed, because you never changed the water cement ratio. And then we included some information about the initial curing standards in New Mexico, and this was put into the mix design submittal so that everybody knew we wanted the cylinders to be properly made during the first 24 hours or 48 if done on a weekend. I would then get certifications of the admixtures from the admixture suppliers. These can now be downloaded off of websites. This one here was a submittal or a certification on the left for air and training admixture, and then a mid-range water reducer 997 was on the right. And then we would include the information about the admixture they're used. In this particular example, I'm showing the RealBuilt 1000, which was a super plasticizer. It explains how it was used and how to use it, what dosage to use, so that the engineer had all the information. And I would always stay with one organization with the admixtures so that we did not have any compatibility problems using 2 different suppliers of admixtures. Here was some information about entrained air, where everybody's concerned about entrained air, so I would provide the information about the entrained air to the engineers for their submittal. But any admixture that you put in, you want to put the admixture information sheet, the data sheet, in the mix design submittal. And then lastly, we would provide an MSDS sheet for the concrete, and along with the super plasticizer if added on the site. This gives the construction people, the project manager on site, or the superintendent, the complete submittal. And if anybody wanted to know an MSDS sheet about the concrete, it would be in the submittal, and the information on the super would also be in that mix design submittal. Thank you very much If you have any questions, you can call me on my cell phone, 505-870-316, or you can drop me an email and I'll get back with you. Thank you very much.